All right, what is theoretical probability? Theoretical probability is the likelihood that an event will happen, or what should happen if we toss a coin. What should happen if we roll the number 2 on a die? The probability of an event is the ratio of favorable outcomes to the number of possible outcomes. So right below is your ratio of what we just said. The probability of an event, and what is an event? Tossing a coin, rolling a die, choosing a card, okay? And favorable is what you're wanting. So if we're rolling a die and we want a 4, how many 4s are there out of the possible, out of total, okay? Which I like this one better. What do you want out of the total, okay? The probability of an event is always between 0 and 1. It's between 0 and 1. It can be 0, it can be 1, it can also be in between. So that's all the fractions and decimals we're going to be working with. So that means between 0% and 100%. Probability can never be below 0% or above 100%. Okay? This number line right here represents the likelihood of something happening. So if it's 0% chance of happening, we're going to say that is impossible. Okay, so these vocabulary are important. If it is guaranteed going to happen, it is certain. Okay, if it's 1/2, okay, that is equally likely to happen. If your probability, and you get a fraction and you do the work, and you get anything between 0 and 1/2, that's unlikely to happen. Okay, so it's probably not going to happen. Okay, if it's between 1/2 and 1/2, it's likely to happen. So you have a better chance of it happening. Okay, for example, what is the theoretical probability of flipping a tails on a coin? So remember we had that fraction. How many tails are on the coin? How many tails are on the coin? There's only 1, right? That's our favorable, or that's what we want. We want tails out of total number of outcomes? 2. Okay, so theoretically, when we toss the coin, we should get 1/2, right? Should. That's theoretical. Okay, what is the likelihood that it will happen? So this is the likelihood here. So what vocabulary are we going to use? So it is equally likely to happen. Half and half, right? Okay, our next example. What is the theoretical probability of rolling a 4 on a die? How many 4s are on a die? 1 out of the total 6. What's that likelihood? Huh? That is unlikely, right? That is less than half. Okay? So that half mark, 1/2, is you're kind of like, is my fraction below or above 1/2? And that's very helpful. All right, now we have experimental probability. Experimental probability is the ratio of the number of times an event occurs. It actually occurs. So experimental is what's actually happening. Okay, so we're going to be doing some actual tossing a coin and rolling a die in a minute. The actual number of trials. Sorry, I repeated that. All right, are we good with that? So the actual number of trials is the total times we're going to toss a coin. The total times that we're going to roll a die. Okay? So we know the theoretical probability for getting tails on a coin from our example above. Now let's actually do it and compare the results. First, let's predict. If we were to toss the coin 100 times, how many times should we theoretically get a tails? 50 times, right? Because we said that was half, right? So we're going to toss the coin 100 times. We're going to record the results in the table. Okay? So since we're going to do it 100 times, I'm going to split the classroom up. All right? And so we'll give you, and then we'll get our class total of 100. Okay? All right, our tally chart's very tiny, so let's start with y'all's group. How many heads did y'all get?
You got 5 heads.
5 and 5. Oh, wow. Okay. What'd y'all get? What'd y'all get?
We got 6 heads, counting heads.
Okay, so do you see already? You know, theoretically, we should have gotten half. You can see the different groups. Did they get half? No. Okay, so, all right, what we do is group.
I got 5 heads.
Nice. All right, now we'll go on individual.
I got 8 tails and 2 heads. I got 6 heads and 4 tails.
Next.
I got 3 tails and 7 heads.
Okay.
I got 4 heads and 6 tails.
Next.
I got 5 tails and 5 heads. Did I skip later?
I got 8 tails.
Okay, sorry. 8 plus 8. Okay, can we add all this stuff really quick with your calculator for tails?
It's 2.
Okay. It is 2. Thank you. 16. So, it's 41 and 16. Really? Very frustrating.
Wait a minute, teacher, you're still
I'm supposed to be recording. Okay, what's 100 minus 57?
42.
We're good with that? Okay, so our fraction, what would our fraction be for tails? 57 hundredths, and heads would be 43 hundredths. All right, so on the next page at the top, so we're going to compare how did our experimental results compare to our theoretical. And it says we're going to subtract the 2 fractions. What were our fractions again? And that equals? Say that again.
14 over 1.
And we always simplify fractions, so that's what?
7 over.
How can we write in words how did our experimental results compare to our theoretical? So what happened here? Theoretically, waning on tails was what? 1/2, right? So it was equally likely, right? But when we actually did it, what was our experimental results? Did we get 50 out of 100? No, we did not. What happened? With our experimental. It was more, thank you. So we tossed more tails than what theoretically should have happened. So based on our experimental results, this is our experimental, if we were taught to toss the coin 500 times, how many tails would we expect to get? So we got 57 out of 100, right? So we can set up a proportion. Out of 500, how many times would we expect to get tails? We were to do it 500 times. 285. How did you get that? Good. Good. Times 5 times 5. So again, it's just a prediction, right? We can get a good estimate if we were to do it 500 times, right? Spend more time on your hands. We should get about 285. All right, so based on our experimental results, if we were to toss the coin 750 times, we can get about what? Huh?
399.
300, say that again?
399.
Exactly?
Oh, no, I thought it was
750. So we should now toss it 750 times. We can predict,
127.
say that again? 427.5. And how'd you get that?
It's exactly right. 57 times 7.5.
7.5. There we go. So we can predict about around there that it should be that many number of times. Are we good? All right. So with your group, we know the theoretical probability of rolling a 4 on the die from our example above. Now let's actually do it and compare the results. So if you to roll the die 24 times, how many times do we theoretically get a 4? So what is the probability of rolling a 4 again?
1 out of 6.
1 out of 6 out of 24 times would be what? Good. Times 4 times 4. So it should be 4 times. Okay, so now you're going to actually do it with your table group. All right, and then what are our outcomes? If we're rolling a die, we're trying to get a 4. What are our outcomes on the die?
1, 2,
1, 2, 3, 4, 5, 6. And then you can keep your tally, okay? And then get the number of times you can make your fractions. But we're trying to determine experimental probability of rolling a 4, right? Roll the dice, but we want our goals, the probability of rolling a 4. Okay, and then with your group, you're going to go ahead and answer the rest of the questions. Okay?